work out for them.
Everybody hates them now.
Yeah, there you go.
They literally fake
So, in case anybody has gotten lost, we are here in CC3 731, and this is also for our friends playing along at home, right? For anyone who is sick today. So then we're going into 87, and one of the things it asks you to do is click the wrench icon located in the upper right corner of the graph, add labels for each axis, so you have to choose what the labels for your axes are going to be. You also can make a scatter plot by using this chart, this T-chart that they already put in. So if I start typing in numbers, it'll make a scatter plot. But before you do that, you should choose your labels so you know what your X is and what your Y is. Is X going to be your time? Is X going to be your distance? That's up for you to decide. That will impact the equation you end up using.
Where's the subscript one?
So Y1 means the first Y point. X1 means the first X. So like this would be X2, Y2, X3, Y3, X4, Y5. Like the subscripts just are indicators of which one. Yep.
I didn't know if it was something kind of like
Today I learned, right?
It was like,
Nope. Subscripts are just indicators. They're not actually like math, they're just indicators. And then we've already talked about line of best fit, but if you need help, let me know. I'm trying to give you guys time to play with Desmos and get more comfortable with this software.
I love it.
Anybody decide that you want to compete in the pie contest tomorrow?
Wow.
How many digits of pi can you recite? Oh, you have one already? Anyone want one? I printed plenty.
I'll try one. Can I bring in my sister?
No.
This is too hard.
Anybody else?
What if I have
Look at the peer pressure. Each person that raises their hand, somebody else is following.
Oh, hey. She's raising her hand. No, not the pie. No.
I know. 3, 4, 1, 4, 3, 1, 9, 8, 9.
All right, I'll take another.
Another?
I'll keep the channel on.
Yes, yay!
Do you actually want one?
Oh yeah.
Okay.
I used to be the pie champion at my old school. but I just stopped.
You were the champ. I
Oh,
Oh, come on. It was right there.
I know. Sometimes things not said are better than things said.
I don't know that I've ever agreed. Well, okay, never mind. I was just going to try to argue with you because maybe I shouldn't say that.
Silence is worth 1,000 words or something. Or a picture's worth 1,000 words. I don't know.
Silence is golden, I think is what you're trying to remember.
Yep.
And since Ponyboy said stay gold, we should probably stay silent, right? What, Sam?
It's golden. What if everyone does this?
In a couple, when we all start comparing our answers, yeah, sure. Can I come look at what you did in Desmos? Can you do it in Desmos to practice using the software like I asked you to do? Hey, Mason, middle school appropriate behavior, please. All right, we will let random cards tell me what to do. Here, we'll even make it more random. Miss Glass, pick a card. All right, Val, how do you want me to label my axes? Do you want X to be minutes or miles?
Well, since the oralized data has time on the left side, I put time as my x-axis.
Sure. So they said click the gear wheel or the wrench. Gosh, gear wrench. My brain is like
I mean,
broken.
gear is another thing used for setting, so it kind of makes
So
sense.
time in minutes, and we can abbreviate, and then distance. So if you did this differently, that's fine, but I'm using random cards. Like Val's card got picked, he told me what to do. So then if my x is my time, I'm going to go ahead and fill in these. 68, 68, 35, 50. Oh, thank you for that catch. I'm zoomed out enough. My eyes are struggling. 17. Is that 35? 3.5. 3.5. 25. 14. 11. Oh, wait, where are my points?
Yeah.
Oh, I have to zoom out. Now, I wonder if there's...
I did the x. I did the distance miles as the x, and then the time as the y.
Okay. So I might open another one of these graphs then and do it the other way around. So guys, if you want to try it both ways, you can open the E tool twice. And I'm going to see, can I copy paste a whole set of data? Nope, it won't let me copy a list. So I'm just going to have to retype it. So while I love doing random cards and letting that determine which, I guess I'm recording and I'm still playing music, so maybe that's bad. So which of these feels like it looks better? Yeah, the second one, right? So while we're allowed to make whatever choices we want, and a lot of times we have time as the X value, because a lot of times we put time on the X value. But here, it looks like that's not really going to show us what we want to see. So I kind of agree with Isaac that I should probably make time my Y value. Guys, it's okay if we do it once and realize, crap, I need to do it again because it'll be better if I do it again. And then distance. Guys, miles is always MI. Minutes is always MIN. We pretty much don't use just M unless we're using it for what? Meters. That just made me really proud. All right, so random card. Sorry, now that Isaac kind of told me we should probably use this XY instead. Guys, if you didn't do your XY with time as your Y and X as your distance, you can still do this. It's just gonna be more difficult. So now I can kind of see a nice trend to my data. Caden, do you think you can help me make a line of best fit? And if you want to, you can come up and drag the points like on the screen. Use the what? Yeah, you can use the board. Yeah, you can just like click on the board and move them where you want to. Mason, while he's doing that, can you remind us what our goal with a line of best fit is? Yeah, we're pretty much averaging things, but when Caden's doing this like with his points, what's kind of guiding where he drops things? You want to pass? Or, I mean, you can keep going or pass, I mean, because Noah's got his hand up. Noah? So we kind of want equal points above the line and below the line, but why did Caden ignore that here? Liam, what do you think about why did Caden drop his line where he did? What did he do specific and what, like, what's your opinion about what Caden did?
Because it's the best fit of line.
But why didn't Caden try to balance out his points and drop like maybe here feels like a little bit nicer? I go through two of them, I got two above and I got two below. You can answer, you can pass, up to you. Bryson's not here. Bryson, I hope you feel better. Adele, thoughts about why Caden didn't? So Caden put his line of best fit here, but it's not quite balancing the points. Why wouldn't Caden have put his line here? And why should we be going through the origin here? Yeah, what this is showing us is it takes Ariel, 12, 14, 15 minutes to go nowhere. So this is like me during the summer. I cannot wait for summer, but I have like a mount on my bicycle where like my phone goes, you know, you got your helmet on, you got your light flashing so no one's going to hit you, and I start recording my ride, and I sit in my driveway for 15 minutes.
Donnelly, please report to the main office. Avery Donnelly to the main office, please.
That announcement was interestingly timed. So I'm sitting in my driveway for 15 minutes. No. I'm like, no. So we're going to expect this to be proportional and probably cross through 0-0. Now, if you still want to try to balance your points, you could. You could bump up a little bit more. But who wants to say anything about, well, not who, sorry, I'm still using cards. These 2 points out here. Colin, can you speak to like these points and why maybe they don't quite match the rest of the data? Say more. What do you mean a lot farther out? They're not really outliers. I heard somebody whisper that. They're not really outliers. They just don't quite match our line of best fit. Guys, I don't know how many of you ride bikes, but like put yourself into this situation. So Colin, give it another go if you want, or you can pass it off. Zach, you raised your hand first.
Because riding bikes isn't like a constant thing where you're going to do the same distance like at the same time.
She tries to ride at a constant pace, but of course, that is not easy to do. Zach, why might these points be below the line of best fit that we just made?
Because you can't, like I said earlier, you can't be at a constant speed at all times.
Yeah, my job as a middle school teacher is to repeat myself, so you're getting to feel a little bit of that when you're like I just said. Yeah, like Zach just said! Guys, riding a bike is not constant, and if you've already ridden 15 miles, you're probably getting a little tired. Guys, they literally make this stuff for cyclists to be able to like reach in their pocket, and it's like goo. Like literally, someone's just called goo. You like rip the top off, and you just like eat this goo stuff because it's got a ton of like carbohydrates and electrolytes, and it's like
It's just calories.
well, not empty calories. I mean, it's like purposeful calories,
It's
right?
like,
And what do calories turn into?
Energy.
Energy. Calories are legit a measure of energy.
It's like
Violet?
I was so surprised because I was at the swim meet and this person just pulls out this like
This
gel. And I'm like,
Yep.
what?
Now they also have like little cookie
It's like
type things if you don't like the gel.
Caffeine
Yeah.
gel.
Yep. My brother-in-law uses those when he runs like long races or whatever. Because he runs, I ride. Mason?
I have an explanation for why she would start at 15.
Okay.
It's because she was in the middle of nowhere and it took her 15 minutes to realize that she was in the middle of nowhere.
So I would still argue she would probably restart her ride clock once she realized where she was and where she was going. The defense I thought you were going to say is she was like stretching. Like before you ride, you should probably stretch. But again, you start your clock when you start your ride. So I think we should probably stick with the origin point. But guys, how...
Isa Raleigh, please come to the Perry office. Isa, please come to the Perry office.
So do you think we should try to, like, how... Hold on, Sam, what are we trying to make a prediction for? No. Noah, what are we trying to make a prediction for? Annabelle? How long it'll take her to ride 30 miles. Do you think I should line a best fit with my shorter distances or with my longer distances? Yeah, we should probably bend our line down a little bit because our longer distances, we see we're starting to slow down a little bit, right? So now, how? So I've got this blue point that I'm going to make disappear, that blue point. If you click on your points, you can make them pop, like show up. The only issue I have is this orange point doesn't quite, like, it won't show up if I click on it. So if I make my line go through this final orange point, is this still pretty close to a line of best fit? Yeah, I got 4 points above, a point below, a point directly on. So how, if I'm going through that point, how, Isaac, can I figure out the slope in this situation? You don't have to give me specific numbers if you just tell me, like, generally how we figure out slope. That's where we're going to. Once we know the m, we'll do mx plus b. How do I find the M? It's okay if you need to pass off. Nick, do you remember what it is to find slope?
Well, slope is delta y.
There it is.
Delta x.
So it's y over x, guys. That's the trap door. A lot of us, because x normally comes first, a lot of us will trap door and accidentally think x over y. It's y over x. Yeah, well, because now my screen's locked. You're good. Thank you for telling me. Yeah, so now whoever's watching YouTube, sorry, Bryson, won't be able to see this in the video because this is only writing on the screen, not on the computer. Does that make sense? So, delta y, delta x, we practiced making these slope triangles, or we can just use the point. Because Caden put us through 0, 0. That's really convenient. What's our y value right here? What's our y value right here? Anybody? Sorry, I guess I've been calling on people, so maybe I should have just said anybody. What's our x value right there? Anybody? 25. Guys, notice, this isn't scaled equally, right? The y-axis is scaled differently than the x-axis. That was on purpose to guide us to trying to put time over there, distance over here. So if I set up 150 over 25, what is that? 6. So our equation now becomes y equals 6x plus nothing, because we're through the origin. Now wait, what is our x here? What did we say x is? What did we make x? We made x distance. So this is number of miles getting plugged in, and y is
Time.
Guys, look up here real quick. If we went with Val's first suggestion, can anyone tell me how our slope would be different? Nick?
We would get y equals 1/6 of the x.
It'd be the reciprocal. Because if we flip around x and y, if we make distance the y and time the x, it would just be the reciprocal. Which is why it looked so much harder to see, because a slope of 1/6 is pretty shallow, right? It's not very steep.
That means
Slope of 6 is steeper, and with how we scaled our axes, easier to see here.
it's like 36 easier. 36 times easier to see.
36 times easier. I love it. All right, so then let's plug in. Well, what are we trying to solve for again, Annabelle? How long for 30 miles? Let's plug in 30. What's 6 times 30? 180. 180 minutes is how many hours?
3.
3. So it would probably take her 3 hours to ride her 30-mile ride. It's
Yeah.
actually pretty good. How many miles per hour is that? 10 miles an hour, right? So that's actually not that fast. Now, we don't know what the course is, if it's a lot of hills or if it's flat or what, but 10 miles, you could ride at 10 miles an hour. Some of you can run close to like 7 or 8 miles an hour. Like riding 10 is not that much faster. All right, so the next thing we have here, we did REL. Let's check this out. If you would like to predict, and guys, we don't have to, we don't have quite enough time to do all of this. If you would like to try to predict the heart rate change for an employee who ran 10 miles a week.
Negative heartbeat.
So, change. Heart rate
Okay.
change.
Okay, good.
Right?
Good.
So,
Good.
bring it back. I want us to do at least one more thing before we're done with class today. If we didn't make a scatter plot here, if we just tried to use the data that we have, like, could you do this? Like, do you think you can make like a y equals mx plus b and all? Like, can we do that without a scatter plot, without a graph? Talk with your partners for a minute or two, and then we'll keep taking opinions from people. But chat with people. Wow, there are people behind you. There are people everywhere. Liam's up there. Like you got people.
I mean, there is a way to do scatter plot
Then open a new tab in Desmos. Open a new tab, make it Desmos. I would like legit open a new tab and just go to desmos.com.
Oh, wait, are you gonna show us Al's work?
Yeah.
Like on the E tool, there's a Desmos button.
Yeah, but you could just get used to just going to desmos.com and clicking graphing calculator.
Or you could just
How do we make a table in here? Colin? The plus button. Table. Oh, hey, look at that. Let's go ahead and put this data into that table.
Plus button.
So again, when we're getting like directions from classmates, let's make sure we look up here. This plus button, add item.
I thought he meant like the plus button on our keyboard.
I don't know if that would work or not.
It
It's
doesn't.
something worth trying. It does not.
It does
Okay.
not. I'm just
So then we have. Are we gonna make? Well, what are we trying to predict? Miles or beats per minute? So, guys, here's the pro tip. You can do it either way, but if you know what you're trying to predict, make that your Y. So, if we're trying to predict heart rate change, let's make that our Y. So this table's set up nicely, X, Y. Go ahead and plug this data in. I need to try to like make this a little smaller so I can show you guys both at the same time. So I'm going to drag this out of there. I'm going to make this bigger. So plug that data into your Desmos. And also, you have the ebook open, so you can go back and forth into the ebook if you need. Actually, I'm just going to plug it in while you guys are plugging it in on your computer. 7. And your X's should be the same amount as your Y's. Interesting. Anyone figure out yet how you can change the color of your points?
no.
Adele?
I just did. So you click the settings button near the little arrow thing.
Like this?
Yeah.
So the gear wheel.
You click the little color.
Now you can also long hold. You can also long hold on the color. So if you like click on it like and hold in the click. So I'm gonna make these red because it's about heart rate. You know, normally red is involved with like hearts. Now this scatter plot feels a little weird. Now crap, wait, line of best fit. Anyone figure out how we get a line onto here?
No.
Noah?
I mean, you can click lines and turn that.
Click what? Click where?
Like go to where you can change the colors.
Like this?
Yeah, and you click on the color.
Click on the color.
And then press lines.
Lines. Ugh. Oh, wait! This is how we can make a polygon! So guys, if you're playing in Desmos, we just figured out how we could make a polygon, but I don't know if that's what we want here.
What scribe do? Oh.
Leah?
If you wanted to add a new line, you could just click underneath it and then do y equals or x equals.
Hey guys, I'm about to blow your mind. Type y equals mx, and I'm not joking. Type y equals mx plus b. Like legit, with the letters m and b. Notice what pops up, add slider. Click all. We can now change our m value with the slider. We can change our b value with the slider. I mean, or you could just manually change the numbers if you want. But if you want to be able to play around with like sliding things. All right, here I got 3 points above, 5 points below. That doesn't look quite good enough. Decide whatever you think your line of best fit is. 3 points. Ooh, I kind of like that one. Anyone spot anything that feels a little suspicious? What, Bradley? There's 2 that end up in the negative area. What? They might be outliers, right? We might be suspicious about, are these out? I would for sure assume that this guy's an outlier. Now this guy was with
The one.
7. No, 7. It was the one negative. So what they were saying was with 1 mile ran per week, the resting heart rate change. So, I mean, he only ran 1 mile. That's not very substantial. I mean, it's good that his resting heart rate went down. I think that's a positive. I forget.
No, it went down because negative.
Ooh, why are we arguing?
Or you.
If we read. I really just wanted you guys to get into an argument there.
Oh my.
A negative heart rate change is actually a gain in heart rate. So all of the positive numbers mean that's actually what they went down by. The negative, because that's what they wanted. That's a positive change. That's good for your body.
Oh, okay.
So because they've made this data represent, oh, that's good versus, oh, that's bad. So guys, we can't really ignore those data. We can't just say those don't exist because we don't like them. Well, we could say, okay, those are probably outliers.
Yeah, when I saw the chart, I was like, I was surprised that there were only 2 negatives because normally when you're an athlete, your heart rate goes.
Right? Yeah, my wife's resting heart rate is lower than mine because she is much more of an athlete than I am.
For some
So-
reason, I do 2 sports and my heart rate's still higher than yours.
Well, that might just be your body, right? And you're young. Your heart rate's gonna be high when you're young, anyways, because you just have a higher heart rate when you're younger.
The RC cars have a heart rate of like 40.
Yeah, because they are such an athlete. Yeah, because when they're really pushing it, their heart really beats. But then when they're doing nothing, yeah, their heart's like, oh, I don't really need to work. Sam?
My mom, she has like a bunch of autoimmune diseases. Her resting heart rate is like 96 to 150.
I mean, that's not really. I mean, that is mildly high, but that's not super concerning.
And then when she
Right.
has to look when she has to doctor prescribe if they're doing something dangerous, it goes up to 150.
Yeah, that's and now that I have my smartwatch, so what my resting heart rate right now, I don't even know how to get to it because I never use this. No, because I'm an anti-Apple.
Aw,
I don't know, somewhere on here I can find my resting heart rate, but
there should be a fitness app.
yes, thank you guys. I just don't use this because I don't want to. I use it for a watch and to see the text messages that I'm missing. All right, so real quick, we should probably finish. Oh, no. Hey, guys, this is a good moment to show you. Desmos will not let you accidentally close it. I just went to try to full screen, and Desmos is like, hey, we're pretty sure if you put work into this, you either want to save it or not close it. So it gives you another chance of hey, did you mean to hit that? No. So if you want to save this, you can save it in your stuff, if you're logged in, of course. So you could just click save, and it saves into your Desmos stuff. So you can always refer back to it. And this is the one we were just doing, so I'm going to click save on that as well. Or crap, no, this is the one that we were just doing. Might as well name that, right? Heart rate or something like that. So real quick, we need to figure out y equals mx plus b for this. I have a few cards I haven't called yet. Lucy, how could we figure out the slope here since we're not using the origin?
Oh,
We're not through the origin here. If we try to assume that this point exists and I can't totally ignore it, but I mean these points, okay, if I tweak, because I think some of you are unhappy that I'm using those points, if I bump that up a little bit to more line of best with those, I'm still not crossing through 0.
So there's a point that's
I'm looking for the vocab that we talked about, right, to show you guys pictures of fences. Do you remember what that word was? Starts with an L.
Oh, lattice.
We want lattice
Yeah,
points.
I
If
found 2 points.
found 2 that can work.
So there's one that is 2.54.
Yeah, and Lucy's is probably slightly different than mine, but I can see what looks to be a lattice point right here, and that's also my y-intercept. And guys, sometimes there aren't perfect lattice points, but here's pretty close. So you want to, if you're looking for slope, find 2 lattice points or close to lattice points. And then again, slope triangle, right? Delta y, delta x, and then double check, do we have a B value? If so, we need to include it in the equation. No?
Is there a way to like write on your graph in decimals?
What do you mean write on your
Like kind of like what you're doing there, but like
I don't know, play with the buttons.
Button, button, button.
I mean, you can't really break it to a point that you've actually broken it. You could always come back from it. So, Isaac? Hey, Val, chill out, man.
There's 3, 3 that works.
Ooh, 3-3. Yeah, that's a nice lattice point. From the side, I can't really see the grid lines. It's weird about my screen. I gotta like actually get in front of it. So if I used 3-3 and 6, 6-7, I think. Then I could have a change in y of so about 4/3, I think, is my slope here. Ish. You should have a slope similar to 4/3, something close to that. It's definitely going to be over 1. Right, definitely going to be over 1 if we're trying to actually fit that data. Now, if we want to force it to use the origin, can we? Yeah, if we say this is going to be proportional, let's make our b 0. So we force it to use the origin. Now what do I need to do with my slope? Do I need to make it steeper or flatten it out a little bit? Flatten it out a little bit, right? So now my slope is pretty close to 1. Actually, guys, if we're playing with m, m's our slope. If you're in Desmos and you're playing with the m value, once you decide, okay, that's good enough, you figured out the slope because this is your slope. Because Desmos does the work for you. All you have to do is be smart enough to know how to use it. And that's pretty much what most of your future is going to be, is utilizing your intelligence to work with computers to make your life a little bit easier. We are out of time. So unfortunately, I gotta let you guys go. You gotta stop playing with Desmos. Oh, okay.
You never showed us Alex's stuff.
Yeah, we'll have to do that another time. Or maybe I'll let him show off at the forum or something. Yeah, if you click the play buttons, things will move on their own.
Yeah. It's fun. It just spins.
All right, real quick while you're packing up, here's Alex's stuff. Like, I gotta get back to it, but so that's what he called Sonic Boom, right? You can see what he named him up here. He also made a Pokeball. Then he started to learn a little bit more and figure out some other things. So he made a flower. If I was him, I would probably change this inner circle. But yeah, click play on what? Oh, click play on this or these? Or oh. And then he made a football. If you can make a football, you might as well challenge yourself to make a basketball. Because we all know it, love it, and shop there. No, I'm joking. He made a target. No, here's his black hole. This is a different one. Oh, it's the same one. He just already has it playing.
And going at like Mach 10.
And then he titled this one Better Spiral. Spiraling out, then spiraling in. All right, get out of here, friends.
That is so cool.
My computer's gonna crash with how much I have going right now.
I made it, Titan.